cool. Okay, so today, it's 5/21/21. Wow, cool. So objective, again, is solving trig equations using identities and today in radians, okay? That's the only difference. We're going to do it in radians today, okay? So example 1. It's like x's and y's. You've got like, in a sense, you've got like a 2y equals an x, and you're supposed to solve, and you can't. You can't because you got two different variables. You can't. So you either have to change a cosine into a sine or a sine into a cosine, but you can't because it's not sine squared. I mean, if it was a sine squared, I could change it. If it was a cosine squared, I could change it, but it's just sine and cosine. But there's a trick. I'm going to change the problem into tangent because these all have tricks. I'm trying to teach you the tricks. If I divide both sides by sine over sine, oh, I'm sorry, how about cosine? My bad. Cosine, rewrite it. Cosine over cosine. There we go. My bad. Then we know that sine over cosine is tangent, right? I mean, that's an identity, right? Sine over cosine is tangent. So I'll have a 2 tangent of x equals, well, cosine of cosine is 1. Now it's not too bad to solve. I'm going to divide by 2, and I'll have tangent of x equals 1/2. I look to my unit circle, but tangent doesn't have a 1/2 value. Okay, so the answer is not in the unit circle, so I'm going to have to use my calculator, okay? Now, since I'm in radians, I'm going to make sure I change my mode to radian mode, right? I'm going to have to go radian modes. That's really going to mess up my third period class because they're taking a test today in degrees, but that's okay. I'll try and get all the calculus back for, okay? So I go to my mode, and I'm going to change my mode to radians, okay, which I have. And I want the angle, so I'm going to do tangent inverse, right?
Wait, how do you do it on the calculator?
So I go to the mode button is right there, push mode, and then you're going to go down. If you're in degrees,
You just click.
you shift it over and push enter. Yeah.
Oh, okay.
Got it? Good.
Yeah, thank you.
Yep. Now we're looking for the angle, so I have to do tangent inverse of 1/2. Now remember, if it's a radian angle, it will appear as a decimal. It will. Think about this. This is an angle. This is an angle. It's 3.14, right? That's an angle. Okay. It's going to look like, this isn't going to look like an angle, but it's in radians. So if I go tangent inverse, let's see, quit. So tan inverse of 0.5 or 1/2, I get an angle. Oh, it doesn't like that. What did I do wrong? Oh, I didn't. Okay, tan inverse of 0.5. There we go. So I get an answer, 0.46. That is an angle. That's going to be x1, which is an angle of 0.46 radians, okay? Now there's a second reference angle. We know tangents are the same 180 degrees away from each other. I check this one. Here's this one. And 180 degrees, the exact same answer, right? Here's a tangent answer, and 180 degrees away is the other answer. So to get the second answer, we're going to take not 180, I said 180, but not 180, but what's the equivalent of 180? Pi, right? So my second answer would be plus pi, and answer about 3.6, okay? How am I doing? Okay, these are a little bit harder, but I'll help you with these, okay? That's my goal. Okay, example 2. Well, example 2 is a little bit like the extra that I showed you. Remember, Chloe, you asked about the extra?
Yeah.
It's similar. So let me put it in terms of x's and y's. If I had a problem that was, say, an x, y equals a 3x, I could bring this over. I could have an x, y minus a 3x equals 0, so that I could common factor out an x and have a y minus 3. And then I have many equations, right? Well, instead of x's and y's, it's just sines and tangents. I'm going to do the same exact process. Let's bring the 3 sine of x over to the left-hand side. So I'll have a sine x tangent x minus a 3 sine of x equals 0, okay? Now the reason I did that is because they both have a sine of x in common, right? So we'll common factor out a sine of x. And when I do that, I'll be left with a tangent of x minus 3 equals 0. Okay? How am I doing? So I got many equations. I have a sine of x equals 0, and I have a tangent of x minus 3 equals 0, okay? Now, this is on the unit circle. If it's on the unit circle, it makes it easy, okay? You could also use a calculator, but sine is 0 at 0 radians and sine is 0 at pi, so my first two answers are x1 is can equal 0 radians, and x2 is going to be pi radians, okay, or 3.14. And I got that because y, sine is the y value, sine is the y value in my unit circle there, sine is the y value in my unit circle there. So that was one angle. It refers to this right back here if you want to grab it. Now, let's do this one. So plus 3, tangent of x equals 3. 3 is not on the unit circle. It's not. Okay, square root of 3 is, but not 3. That's okay. We'll just use our calculator. I'll do the tangent inverse of 3 if I want the angle. Okay. And I'll just use my calculator clear. I'll go tan inverse of 3, and I get an answer of about 1.25. And that is an angle, right? That's an angle. 1.25 would probably be around here somewhere, right? Pretty close to that. 1.25 radians. But there's a second answer. That's x3. x4, you know, tangents are 180 degrees opposite of each other. So I'll take my 1.25. I'm not going to add 180, but I'm going to add pi, right? Because pi is the equivalent to 180, but in terms of radians. So I'll add pi to that, and I get an answer about 4.4. Okay? I'll slow down and let you catch up, okay? I'm hoping that I'll have time to help you with some homework today. Now remember, all you got to do, Zoe looking at me, all you got to do is try. Even if you totally get them all wrong, all you got to do is try them, right? Say, yeah, I got you, Mr. Davies. Okay? Okay. Number 3. Now, number 3, I give you a hint. It says square both sides. Because you got a sine and a cosine, it's like having x's and y's. It's not going to work. So if I square both sides, okay, that's the hint. Square both sides. Let's see how that's going to help. Okay? So if I square this side, I'll get a 4 sine squared of x. And again, I put the square here. Everybody remembers that I talk about how if you square it, this little square goes right there and it represents. This square right there represents it being on the outside. I squared the 2. This one I'm going to have to write twice because it's quantity, so it's a cosine of x plus 1 times another cosine of x plus 1. Okay, and I'm going to have to FOIL that out. Okay, let's see what happens. Cosine times cosine is cosine squared of x. Cosine times 1 is a 1 cosine of x. And then 1 times cosine is a 1 cosine of x, and a 1 times 1 is 1. Okay? All right? That makes 2 of those, right? So I'm going to have a 4 sine squared of x equals a cosine squared of x plus a 2, because there's 1, 2 of them, cosine of x plus 1. Okay, now here's my dilemma, and I'm going to make it easy. Okay, you can't change a cosine into a sine, but you can change a sine squared into cosine squared. I can change this into cosine squared, and everything will be in terms of cosine. So I'm going to change my sine squared, and the identity, and I'll write it down. The identity is that sine squared is equal to 1 minus cosine squared. That's my identity. So, and I'll write that up above, that we have an identity. Okay, a little identity. We know that sine squared of theta, or x in this case, is 1 minus a cosine squared of x. And I want to use that identity so that I can change everything into terms of cosines. I'm going to put that right there, okay? All right, so I'm going to rewrite this as 4, and I'll rewrite the sine squared as a 1 minus a cosine squared of x, of course, an equal to cosine squared of x plus 2 cosine of x plus 1. I'll let you catch up, okay? So I just made a substitution. I wanted everything in terms of cosine, so that's like having the same variable all the way through. So I have just, in a sense, x's or whatever, but I have the same thing all the way through, which makes it easier to solve, okay? Whew, this is a big problem, huh? That's why the last example, okay? All right, let me go ahead and distribute. I'm going to go that times that, that times that. So I'll get a 4 minus a 4 cosine squared of x equals a cosine squared of x plus a 2 cosine of x plus 1. Okay, now, it's like algebra, okay? It's like algebra. If I had, I'm going to bring over the 4 cosine squared of x by adding it. So I go plus 4 cosine squared of x plus 4 cosine squared of x, right? I'm going to go minus 4, and let's see what I have. Okay, we're going to have 0 equals, I'm going to factor in a second, 0 equals a 5 cosine squared of x plus 2 cosine of x minus 3. Okay, hopefully that'll factor. Yeah, it will factor. Perfect, it will factor. Little side note, if I have a 5x squared plus 2x minus 3, 5x, x, 3, and 1. Let's see, I need a positive, negative. Yeah, that'll make a negative 3, positive 5. It does factor, right? It does factor. So this will factor too. But in terms of cosines, I'll go 5 cosine of x minus 3 times a cosine of x plus 1 equals 0. Okay? How am I doing? That's a hard problem. How's your head, Zoe? Am I giving you a headache? Okay, we got a many equations, right? I've got a 5 cosine of x minus 3 equals 0, and a cosine of x plus 1 equals 0, right? All right, so plus 3, 5 cosine of x equals 3. Divide by 3, cosine of x equals 3/5. Oh, it's not on the unit circle. 3/5 is not on the unit circle, but that's okay. We'll use a calculator. Cosine inverse of 3/5. So give me my first angle, okay?
It's going to be on the test.
Oh, maybe it's an extra credit problem. It's a great extra credit problem. Right? You agree with that? And I get about a 0.927. Okay, so first answer, x is equal to a 0.927. Okay? Now cosine has another answer. Now what we find in cosine is the 1/2 here would be equal to a 1/2 here. So what we find with cosine is that 360-degree revolution would get me to the other reference angle. So I can take, not 360 though, not 360 but 2 pi, so theta 2 would be 2 pi minus my 0.927. Give me my second angle minus my answer. So I get about a 5.3 5.35, 5.34, nope, 5.36 is my second angle, okay? Now, the next one's easy because it is on the unit circle. Okay, I'll let you get you caught up. And I'll go -1, so cosine of x equals -1, and that is on the unit circle right there at pi. So my third angle is pi. Okay, so homework, 326, 9 through 16, all, x is 19. So all you have to do, you have to try, okay? I understand these are hard.